on paper. Like you have to press down to like write with it. There I had these special pens. They're cheap. It's like $20 for like 100 maybe. And you really barely touch the paper, it's already putting ink on there. Yeah.
I've been testing pens.
All right.
The best pen.
Yeah. What's
So
your best one for me? Oh, yeah.
if I had something like this, and I needed to find the derivative, use derivative denoted by this, 3x squared. Remember, we bring the exponent down front, and the lower the exponent by 1, plus 10x to the first. Okay? So that's the basic. Okay? Then we talked about what do we do when we had something like this. Let's do 5x squared plus 3, and then 2x to the third minus 4x. Okay? So this would have been one of the ones. I can't believe I screwed this up. So we basically, if you call this u, you call this v, it becomes u times the derivative of v times the derivative of u. Okay? So u is just this. And then the derivative of v is going to be 6x squared minus 4. I got to move this over. And then I have v, so it's going to be plus v, so 2x to the third minus 4x, and then times the derivative of this is going to be 10x. Okay, so that's everything we've done so far. And then we actually have the quotient rule too. So if I had, so this is its own, this is its own, and let's move down a little bit. Well, let's say we had this. You have a question for me? X to the third plus 7x. So when we have this type of situation, we're going to call the top u, call the bottom v, and basically it's going to be v times the derivative of u minus u times the derivative of v all over v squared. So if we go through that, the derivative of this is going to give me 2x plus 3. The derivative of this is going to give me 3x squared plus 7. So just plug them directly back in. So v, so y prime is going to be v, which is x to the third plus 7x, times the derivative of u, which is going to give me 2x squared plus 3.
I think it's just 2x.
Yes, it is. I don't know what I was doing. Thank you. And then minus our u value, which is this, times the derivative of that, 3x squared plus 7. Is that right? Yeah, I think so. That's right. All divided by the denominator quantity squared. Okay? So those are the three things that we hit so far. Okay. Are we all right so far? There is one last one. It is called the power rule. Can I move off here? So what are we going to do in this situation? Okay, there's got to be a derivative way we can find a derivative of that. So a few things that we can look at. We can say, okay, I could move this whole denominator up, and then I can convert this into x to the second plus 1 raised to the negative 3/2 power. Okay, and this conventionally doesn't do the greatest job of any of the other properties of it. I mean, it looks like because it's a fraction, you can do the quotient rule, but you still get stuck when you have an exponent outside a quantity. All right, so if I want to find the derivative of this, ready? I can do it. All right, so I'm going to get the derivative of the outside, okay, times whatever the inside was, but then I have to go minus 1. So in this case, I'm going to subtract 2 over 2, which is going to give me the negative 1/2 power. And then I have to take the derivative of the inside.
Would it be minus 5/2?
Yeah, because I did that. Thank you. So negative 3/2 minus 2 over 2 is negative 5 over 2. So this as a cleaned up derivative, I don't know, we could maybe do this. Maybe say this. And that could be the derivative. And that gets pretty nasty. Okay? So this particular rule in simplistic form is if you have to do the derivative, exponent minus 1, derivative of inside parentheses. Okay? Now, with that said, we should be able to finish up those problems. Now, I forget, did I give you just 1 through 6 yesterday? Does that sound about right? On 4-5?
Mm-hmm.
Cool. Let's review these, make sure we feel comfortable with it. So problem number 1, we have f of x is equal to 1 over. All right, this is one of the new rules. Agree? The new rule I just went over. So I'm going to change that to f of x equals x squared plus 2 raised to the negative 3 power. So negative 3 power because I moved it out of the exponent. Okay? If I want to find the derivative of it, I'm going to go negative 3, so that came down front, times the quantity, and I need to subtract 1 from that, so it's now to the negative 4. And then I need to take the derivative of the inside, which is 2x, and then let's see if we can just clean it up a little bit. So negative 3 times 2x, I guess we could multiply those together, over this quantity to the 4th power. So I guess ultimately cleaned up, you could probably say this is the derivative here. Okay, so why did it move back downstairs? It moved downstairs because it was still raised to a negative exponent, so you changed locations. The math world sometimes gets frustrated if you have negative exponents. In reality, they just need to fart and relax, not worry about it. Okay, so that's problem number 1. Can I go to problem number 2? I don't know. Can you, dude? No. Okay. Getting mean about it. Can I move? Everyone have that copy down? So in my second period stats class, I'm up here teaching. Halfway through the lesson, Mr. Stirrup, it's not up on the screen. I'm like, couldn't have told me that like 10, 15 minutes ago? Well, you didn't look. No kidding. All right, this one, we're going to get x squared plus 4x raised to the negative 2. This is our new property. Agree? So g prime, take the derivative. So this comes down front. I get negative 2 out front. X squared plus 4x. This is going to subtract 1 for that, so I get negative 3. Then I'm going to do the derivative of the inside, which is 2x plus 4. Clean it up a little bit. The negative exponent can move back downstairs. Becomes a positive exponent. I guess if you clean this up a little bit more, you could get away with this. And that's your derivative there. So it's not a real hard property, but I gave you an assignment and you're like, forgot to teach us something. Yes, I did. Can I go to number 3? Anyone need more time? Everyone agree with my derivative so far? They told me I didn't know how. Did you need that still? I'm sorry. They told me I didn't know how to teach derivatives. Clearly, I can't. Good. All right. This is also one of our new properties because we have this. So I need to convert this to this. That's going to be raised to the 1/2 power. So to take the derivative, the 1/2 comes out front times this. And I'm going to subtract 2/2 from it, so that's to the negative 1/2 power. Okay, why negative 2 or why 2/2? Because that's the same thing as 1. And then I have to do the derivative of the inside, which is 2x plus 4. Let's clean it up a little bit. So I get 1 over 2x plus 4 over the square root of x squared plus 4x plus 5. I guess you don't really need that 1 there. Oh, and I forgot a 2. Ah, man, can't take me anywhere. And I guess if you really wanted to get really fancy, you could, this is for 100 million bonus points. So I factored a 2 out. This 2 cancels this 2. So truly my cleaned up derivative looks like this. Yeehaw. So, what else should we do today other than the rest of these problems? You guys want to play with matches?
Yes, absolutely.
Yes, best day ever. What'd you do in Storp's class? We lit stuff on fire. Are you done? Good. All right, number 4. Go for it. So this is one of the properties I had taught. Okay. So if you call this u, you call this v, then we're going to go u derivative of v plus v derivative of u. Okay. So the derivative of u is 5. The derivative of this is 2x minus 2. So just plug them directly in. So derivative u is 5x plus 3 times the derivative of the other one, 2x minus 2, plus v, which is this, times the derivative of the first, which is 5. If you really wanted to get really cool, you can FOIL this out, distribute over here. So you get y prime equals, let's see if I can do this. That's 10x squared, 6x minus 10x minus 4x minus 6 plus 5x squared minus 10x. Combine like terms, 15x squared minus 14x minus 6. There's our derivative. Did you guys figure out what you're going to tell Principal Silva so I don't have to go to this meeting? It's got to be good.
You had a heart attack. You died.
I like this kidnapping. This is good. Let's make a story out of it. Have a movie. Sell the rights to Netflix. It'd be awesome.
Heart attack.
Okay, so if you guys know, I will be here early on Monday. I have to get over to Arapahoe and Jordan by 7:30. So I'll probably be leaving here about 7. I like this kidnapping idea. So I usually park right over here, got a white little electric car. Okay, maybe an unmarked van. You guys swing by, throw me in the van. I think that might be the best excuse ever. I like this. All right, number 5. Oh, now we have P's and Q's. Great. We're changing variables. That always goes over well. All right, this is one of our quotient rules. So I have U on top, I have V on bottom. So I'm going to go V times U minus U times V prime over V squared. Okay, we got this. So the derivative of this is going to be 2Q. The derivative of this is going to be 2. Let's plug it all in that we know. So we got V, which is, so P prime equals 2Q minus 1. Derivative of the top is 2Q minus U on top. It's going to be Q squared plus 3 times the derivative of the bottom. Never mind. I just brain farted. And then I have 2Q minus 1, quantity squared. So if you wanted to clean it up all the way, let's see. I'm going to get 4Q minus 2Q, 4Q squared minus 2Q minus 2Q squared minus 6 over 4Q squared minus 4Q plus 1. Moving on down, combine like terms. So like term. So I'm going to get P prime is equal to 2Q squared minus 2Q minus 6 over 4Q squared minus 4Q plus 1. You cannot reduce the Q's or the Q squareds because they're all together. Then we get to number 6. We do product rule with quotient rule.
Mm-hmm.
Yeah? Is it really that much?
Yeah.
I'm not going to go that hard.
Can we just boil it out?
That's what I was going to do. I really can't remember that rule. It's been too many years. All right, so we came across this. The problem is it's a product rule and a quotient rule all in one. I would FOIL this just to make it a quotient rule. So I'm going to get x squared minus x minus 2 over x squared plus 1. I have u on top. I have v on bottom. My derivative is going to be, God, why can't I remember this? VU prime minus UV prime over V squared. Prime. All right, so the derivative of the top is going to be 2x minus 1. The derivative of the bottom is going to be 2x. Our derivative is going to be V, which is x squared plus 1, times the derivative of the top, 2x minus 1, minus our u value on top, x squared minus x minus 2, times the derivative of the bottom is 2x, all over x squared plus 1, quantity squared. And then algebra 1 is going to help us clean this up. So FOIL, distribute. So f prime at x is going to be 2x squared is cubed. Yeah, I just saw that. Cubed minus x squared plus 2x minus 1. Distribute negative 2x to the third plus 2x squared plus 4x, all divided by, x to the fourth plus 2x squared plus 1. And I just did some fancy math, and I might have lost a couple people. That cancels that. That's beautiful. This combines with that. I like it. this combines with that. Minus 1 over x to the fourth plus 2x squared plus 1. Oh my gosh. Do we have to know all that? I can assure you the quiz on Monday on Schoology is not going to be that dirty. Deal? All right. All right. On that page, that'll work. Would you do worksheet 4-5? So do 7 through 9. Yeah, we'll call it good 7 through 9. Revenue sold, marginal. Okay. And I'm going to say try 10. So it would be basically you're going to do the derivative and then plug 100 in to whatever the derivative is. Cool? That's all I have for you. Do you guys want more?